Hello everybody, welcome to yet another video by JFB, and in this video I'm going to teach you about converting from denary to hexadecimal. If you didn't watch my previous video where I explained what the hexadecimal system is, please go back and watch it because it will help you understand this video even better. So a brief reminder, remember the denary system is a system we use in our everyday lives to do all kinds of calculations, whilst the hexadecimal system is even rarely used in our lives, but it's used mainly in computer science for good reasons which I'll show later in another video. The denary system uses base 10. It uses base 10, whilst the hexadecimal system uses base 16. And again, if you don't know where these bases are coming from, watch the previous video. I explained about where these bases are coming from, and in this video I'm simply going to show you how to convert from base 10 of the denary to base 16 of the hexadecimal. To start off the conversion process, we're going to start with a relatively simple example, and that example we're going to use the number 221, converting it from the denary system where it is right now to the hexadecimal. You draw a table first of all, and in that table you simply split it up into rows and you write the number you're trying to convert from in the middle, 221, and leave this column empty right now, and the base you're trying to take it to, and we know the hexadecimal system is base 16, that's where we're trying to take it to, so we write a 16. Then divide the number here repetitively by 16 until we get to a point where we have 0 0. You see where these two zeros will come from. So 221 divided by 16 is 13, remainder 13. Now I'm not gonna write a 13 here, as I explained in the previous video that in the hexadecimal system we don't use numbers like 13 and 10, because 10, for example, is used by 1 here, and it's also used by 0 here. So we have to find another way of representing 10 in the hexadecimal system. That's where we use 10 is represented by an A, and 11 is represented by B, 12 by a C, 13 by a D, 14 by an E, and 15 by an F. We are using these letters to represent these numbers because these numbers are already composed of digits which are already being used. So 0 is being used by 0 itself, 1 is being used by 1 itself, so we can't use it again. Instead, we have to find another way of representing these numbers. Luckily, mathematicians discovered a fancier way whereby 10 can just represent by L, and you can go on 11 by B, 12 by C, 13 by D, 14 by E, and 15 by F. So where we're supposed to write the remainder of 13 here, we're instead gonna write the remainder of D, where D is actually representing the 13. You divide 13 again repetitively by 16. You continue the division process until you get to a point where you have 0 0. So 13 divided by 16, 16 is bigger than 13, so it can't go into 13, and the answer is 0. Your remainder is 13. Now we're not gonna write 13 again, instead we're gonna write a D here. Sorry for this mess, but you get the point. Instead of writing the 13, we write a D, as 13 in the hexadecimal system is represented by a D. Then you continue dividing. 0 divided by 16 is 0, remainder 0. So we have reached the point where of 0 0. Then you read your number from bottom to top, and that gives you a 0, D, and D. This is a 0, by the way. So 0DD, that's your answer. So I've opened up a Google tab to show that the answer we've gotten is actually correct. It's 221 to hexadecimal is 0DD. Oh, don't mind this 0x, it's just showing that you're in the hexadecimal system. 221 to hexadecimal is DD. That's all. Moving on to another example, we're gonna convert 1152 as our final example, and hopefully everybody gets the main point. The main point is that you're repetitively dividing the number by 16 and taking note of the remainders. That's all. So 1152 divided by 16 is 72, and there's no remainder for this division, so it's a 0. 16 into 72 is 4, and the remainder is an 8. 4 divided by 16 is 0, as 16 is greater than 4, but the remainder is the 4 itself. Then you continue dividing. 0 divided by 16, it's 0, and the remainder of 0. You read the number from bottom to top, and that gives you a 480. You can ignore this 0 0, and that's your 1152 in the hexadecimal system. To explicitly even show that this is in the hexadecimal system, you can write hexadecimal, so that people won't get confused that, wait, did he just convert a number from the denary system to another number in the denary system? How is this possible? How can you convert 1152 to a lesser number, 480? But when you simply explicitly state that this is in hexadecimal, everybody will know that now that is genius. You have just converted the number from 1152 in base 10 to 480 in base 16. That's all. And with that, I'm gonna wrap off this video, as this process is very easy. Just repeatedly divide it by the number by 16 until you get to a point where you have 00. Read the number from bottom to top, and boom, you have converted the number to another base. Thanks for watching this video. Please leave a like, subscribe, and share.